Thank you for joining us for this very first episode of the Above and Beyond webinar series. My name is Andy Toro. I'm a client service manager at SmartIS, and I will be helping to facilitate the event today. For our agenda today, we've got two speakers. First is Veronica Hill. She's our WMS practice manager, and she'll just be telling us a little bit about who SmartIS is and a little bit about our WMS practice. Then we will go into our keynote presentation with Saad Ahmad, our Executive Vice President here at SmartIS. And after that, we'll go through the Q&A and then play our trivia. So with that, we'll let Veronica Hill take it from here.
Thank you, Andy. What a great turnout for our first event. I'm Veronica, the WMS Practice Manager here at SmartIS. Some of you know me, but I did see some new names on the roster, and that's very exciting for us. So a little bit about me and a little bit about SmartIS. I've been with SmartIS going on 11 years now. My background is in logistics and operations. SmartIS has grown greatly from our start in 1988, expanding from our corporate office located in Oshkosh, Wisconsin, to our location in Pakistan, and now to our office in Germany. No matter how much we grow, one thing remains the same: our philosophy to build long-term strategic relationships with our customers through successful, results-oriented technology services. We strive to offer best-in-class management consulting, technology consulting, and managed services all under one roof. At SmartIS, we have decades of experience in the JDA Blue Yonder software platform. With our team being led by ex-Red Prairie analysts and developers, we've completed implementations around the globe and currently provide 24/7 managed services to major organizations. We understand the product and the space, so we are uniquely positioned to create innovative products to solve complex problems. While we do not have time to discuss those here, I urge you to go to our website and check them out. They're cool. Implementation, managed services, upgrades, audit management, custom enhancements, training, or like today's topic, integration. These can all be challenging and can all vary in complexity. That is why a partner with the experience and expertise found at SmartIS is necessary to help you meet and exceed your goals. And with that, ladies and gentlemen, brings us to our presentation. I would like to introduce to you our Executive Vice President, Saad Ahmad.
Hello, everybody. Thanks for joining us today for the first of our series. So a little bit background for me, I've been working in technology space for close to 30 years. And with Blue Yonder WMS, McHugh Freeman, all those names for close to 25 years. So I started with that in 1994. So I have also worked at Blue Yonder in the architecture team there and in functional teams there. So I understand the software quite well and the philosophy and the concepts behind it. Basically, today's session is going to be around the Integrator platform, which is available. But before that, I want to cover a little bit about the series, right? So this is one of several, and we would hope that this continues as we go forward. So far we have designed 5 episodes, and we would look forward to your feedback around it if you want to have some other topics covered as well. So this is the first one, which is about Integrator. And a very important topic these days in Blue Yonder space is the cloud. So that is going to be our next episode, where we would cover what it implies that Blue Yonder is running in cloud. We would also then have an episode around making customization, how to build software enhancements and those concepts. There would be an episode on strictly performance, because that is a very important topic to consider. And then we would have an episode about certain typical design patterns, like what kind of enhancements can be done to solve what types of problems. So that would be a series, and we would look forward to your feedback to add more. And we hope that this is a continuing platform where we can discuss these topics. So now on to the topic of today, which is about Integrator. The way I've divided this up is into these 5 sections. So I would go over the core concepts. I think that understanding the core concepts and philosophy of a software is very important because that is what really allows us to describe the problems correctly, describe the solutions correctly. So concepts are very important. Then the big picture, like there are several solutions who try to solve the integration problem. So then we are trying to describe what is the big picture, how does Integrator view the world. I would go a little bit into performance tuning, some typical issues around performance, some advanced troubleshooting techniques. And then at the end, I would go over data dictionary, but keep in mind that we would have all of this available at our website afterwards. And so, the concepts in data dictionary, because since that would involve a lot of information, that just don't worry about it, because that would be all available at our website as well. So now about the concepts. In concepts, the glossary and terminology of a system are very important. Oftentimes we do not describe problems or enhancements or solutions with the correct terminology, and then that leads to confusion, and we don't understand the context of a specific issue and philosophy. So in that space, a system, what Integrator calls a system, is a very critical concept. If you consider integration as a play, then systems would be the actors in that play. So you would have a typical system like host, which is a generic name for any host system that might be talking to Blue Yonder WMS. DCS is a reserved name for Red Prairie's own, one of its WMSs. So that is what you would have. If you have automation systems, you would see some of those names there. If you have a parcel system, you may see those names there. If you have SAP, you would see that here. So that is what a system is. So then most of the time when systems are communicating with Blue Yonder, they send data to Blue Yonder. So that is called inbound IFD. So IFD here stands for interface document. That's what IFD stands for. So inbound IFD is when data is sent to us. So a good way to, a good analogy for inbound IFD is that it has segments and fields. So, that is also the philosophy of Integrator as well, that it views them as tables. So that's a good way to imagine what this is. This is, so you can say that there's a ship order segment is a table and it has certain fields in it. So if you think of it that way, then some of the concepts underneath it would make sense. Then we have a concept of event. So that is something which is often misunderstood, and we sometimes think of events as inbound events, outbound events. That is not what Integrator's philosophy and concepts are. Integrator thinks it is an event is an event. There is no such thing as inbound or outbound. So the right side, what you see right now, is something I would say is very elegant, in that it is talking about item lot change event. And then as you can see, that event's output is going to an external system like Hub, and also Red Prairie. So which is basically describing a situation which is not atypical. This is a real world situation that WMS itself can change lot, and also somebody else can change lot. So that is now how Integrator wants to be used, that you should be sharing the event in those cases. So again, very important insight, that if we think about events as events and not as inbound and outbound, certain new concepts are cleared up. So then there is a concept of algorithm. So algorithm you would see all over the place, field level algorithms, blocking algorithms, etc. So these are basically places where you can write a piece of software to create a small enhancement in a different behavior. Very important insight here is that every algorithm is in a group, and those groups are prefixed with SL underscore, but there are unfortunately groups which are not with SL prefix as well. And some of them are unfortunately standard as well. But very important insight is that try to create algorithms and put them in the groups which are for them in SL underscore technical groups, because some of the screens show the algorithms which are in a specific group based on that division. Otherwise, it doesn't make any difference other than the fact that certain screens will not show your algorithms in those places. Then, as we described event, so event is something occurring in that integration play. And then when an event occurs, it passes in scalar input. Like if your trailer got dispatched, it would say this is the trailer ID. If inventory got moved, it would say this is the pallet ID. So but we really, for example, if a trailer is leaving the facility, we are interested in its shipments on it, stops on it, inventory ID on it. So those are the information which is extracted in the form of event output. So that is something where we start with the scalar input of the event, and we then keep expanding and expanding and create a large data set, which is the event output. So that's what, so event outputs are created. You can create them using SQL, or you can create them using Mocha commands as well. General, like a small tip here would be that always default to Mocha commands. They give you a lot of flexibility, but that is a little bit up to the specific context as well. Then we have result IFT. So event output, the event occurred, like shipment dispatch, its output is captured, but you probably need to send it to a specific system in a specific layout. So those are result IFTs. That is where your format is biased by how the other system wants it. So they have two types, generally, broadly speaking. Either you are interested in structure of the data, which is typical when we are talking to another system, or integrator also considers when you want to execute something directly, that is also a result IFT. What do we mean by executing directly? Like many times when you are getting data into WMS, Blue Yonder WMS itself, you are not creating another file for Blue Yonder WMS. You are actually trying to create the item. You're actually trying to create the receipt. You're actually trying to create the order. So integrator considers that as a result IFD as well. So these are just broadly speaking two different types of result IFDs. Then we have communication mode. So that is where we would have asynchronous communication, synchronous communication, or synchronous accept send. So synchronous accept send is, I would cover more of it later, but that is something which is unfortunately not used more often. That is many times a silver bullet for some of the performance issues. So, but imagine that asynchronous is something where the data is sent to the other system later on. Synchronous synchronous is something where it is sent in the same transaction right away, and synchronous accept send is something in the middle. So that I would cover a little bit later on as well. Communication methods. This is another very important concept. Very important insight here is that there is not much code within core integrator about communicating to specific systems themselves. So that also speaks to a little bit of the elegance of integrator, but also that you can create custom communication methods, and that should not be something which you should be too scared about. So communication methods are basically algorithms, and algorithms are Mocha commands. So oftentimes I've seen that sometimes requirements get overly complicated because we sometimes think that communication methods are too sacred to touch. They're not. They are just fine. We just need to know how to make the changes, but they are sometimes making changes at that level often provides us flexibility to make very small amount of change to solve the real problem, whereas otherwise it would have been a very convoluted change. So communication method are just Mocha commands. We have to understand the philosophy behind it, and changing them is not such a big deal. And then system communication is where you actually try to use that communication method for a specific system. That is where you would give the folders, system IDs, queue names, that is all at the system communication method. So there, another very important thing that when we are doing projects, we never ever put literal hard-coded values as system communication arguments. So we would never put like a f:/file path here, never, because we always use environment variables. The reason being that all organizations would sometimes copy production down to QA. So I never want to get that call at night that, hey, QA has started to consume the orders from production or vice versa. So that is why we would always put environment variable reference when we are referring to communication method attributes. So that's a little bit about terminology. So we should know when we are describing a problem enhancement that this is the terminology according to which integrator. Then this terminology is also very important to when we are looking at screens in integrator. They would also be talking in the same language. So now there are two ways that we can invoke integrator. Method one, this is just our own terminology. This is not something which Blue Yonder calls it. But method one is basically where integrator is invoked by calling the mocha command SL log event. Right? That is how Blue Yonder's own native systems would invoke integrator. So that means that there is a piece of code, trigger, or something like that, where it calls SL log event, passes in the scalar input and the event ID, and that is how integrator is called. So that is the system here is the DCS system. Event is what the SL log event called. So at that time, as soon as the event is called, it would create the event outputs that are needed. As we described, event output is basically if you have, for example, trailer dispatching, it is all the information about trailer, like what stops, shipments, inventory, and etc. Then the next step is result IFD. So after your event has been created, event output has been created, then result IFDs are created. And then result IFDs are sent to multiple systems. So one event output can create multiple result IFDs. That is a very important insight that we should try to share the event outputs when we have new messages that we have to send to somebody. And one result IFD can be sent to several systems. And the question mark here means that we can define when to send a specific result IFD to a specific system. And integrator is intelligent enough that if it determines that all result IFDs are blocked, then it would not even create the event output. So it would not waste time in that effort. So basically, this is if it is a synchronous transaction, then as soon as SL log event happens, data goes to the other system. That's a synchronous. Asynchronous means that it only goes up till event output. And synchronous except send is where it would go until result IFD. It would still not send to the other system, but it would go up till the result IFD. Again, I would cover more of it later, but that is what we call method one, how native Blue Yonder systems call integrator. So method two is typically how external systems like SAPs of the world, host systems would talk to integrator. In that case, what happens is that those systems, like system here, there would be like SAP or host, something. They create downloads. Now, what is a download? It could be a file, it could be a queue message, any of those approaches. It would create a download, and integrator would figure out what inbound IFDs are in it. So as I said earlier, inbound IFDs should just be imagined as tables, and that is what integrators' own philosophy is as well. They don't never become physical tables, but that is a good analogy. So all you should imagine is that as soon as these transactions were sent to integrator, just magically integrator got these tables in the form, the segments in the inbound IFD are tables, and they are available when the event gets logged. So see the event output result IFD system, that is exactly the same as method one. And that is why it is very important to not consider events as output or input events. Events are events. Either they are getting data from inbound IFD or they are getting data from the native WMS systems. So that is a very important consideration that we should always consider an event as an event, and then that is once you're clear on it, that's when you would then see that there's a lot of opportunity to share the same events. So now just to summarize some of the important concepts that we have discussed. that whenever we are talking about events, always consider event as an event and not as an inbound or outbound. And when we are retrieving data for it, do prefer Mocha to retrieve data. That allows a lot of flexibility down the line. Because Mocha algorithms can use pipes, they can call other Mocha commands, there's a good reuse of code. So generally speaking, our rule of thumb is that we always prefer Mocha commands when we are retrieving data. Event arguments are available for events like ship ID, but a very important insight there is that event arguments, you can add custom event arguments to standard events as well. And Mocha has a very nice feature of Mocha functions, and those can be called as event arguments. So oftentimes that alone saves a lot of time and effort, that there was some piece of data that was needed, and we can just easily add that as an event argument, and it then opens up a lot of possibilities to make simpler solutions. Another very important consideration is that just consider inbound IFDs segments as tables. If we consider them like that, then a lot of concepts would open up. Use sync except send when we are defining transactions to the other systems. Always use sync except send. Don't use asynchronous. And never get intimidated by communication method. Try to figure out what the problem is. If communication method is what needs to be changed, then just understand that those are just Mocha commands as well. And never hard code communication method attributes. Environment variables can easily be referenced, and they basically make the overall experience of supporting much easier, because you can sleep better that under no situation would QA start consuming data from production. So whenever we look at certain screens, this big picture that I have up front on top is very important. That is what different statuses are referring to, and that is what would open up, clear up some of the concepts, what different things are talking about. So when we are in an event query, that's a standard screen in all versions of Red Prairie. So EC status means that we have event and event output logged. That's what EC status means. IC means the result IFDs have been created, and SC means that the result IFDs have been sent to the other system. So SC means that all is done and nothing is left to be done. EC and IC are transient status, that they stay in that status for a little bit and then they have to move to the next status. EE means that there was an error while creating the event. IE means there was an error creating the result IFD, and SE means that there was an error while sending. So if you are an asynchronous event, then your event would go to EC, then IC, then SC. If you did synchronous, then your event would only go to SC or EE. But synchronous except send, that is what we should start thinking more. Then it means that as soon as you log event, it would go to IC status on success, and then another process would send it later. So that is what different statuses refer to when we are looking at the various integrator screens. So when another system is sending data to us, then there is a concept of download that comes, is that that system sends us downloads, and downloads could have several inbound IFDs in them. Consider download as somebody sending us a file. Consider download as somebody putting a message on the queue. Those are downloads. And inbound IFDs as that we extract from the download what actual transaction it is, like order segments, and whatnot. So in those cases, the statuses of download are ID means that we know what download it is, like this download came, it had a ship or transaction. If we figure that all out, then it is an ID. From ID, it goes to eproc. So eproc is a transient status, which means that it is just saying that it is logging the event at that time. And then it goes to edone, which means that event has been logged successfully, and error, which means that there was an error. So eproc is a transient status. Nothing should stay in that status for long. If it is staying there, that most likely means that what it was trying to do, for example, sending data, creating a part, creating an order, that process crashed, and that is typically what would leave a download in eproc status. Defining an interface document is a concept of data layout. So that is where you would say that it's a CSV, fixed byte, those make sense. But if you see here, there is no XML here. That is a very important consideration to know, that Integrator considers XML as a communication detail Integrator does not consider XML as a interface document detail, which means that it would store data in one of these formats internally, and then while communicating to the other system is where it would convert it to XML. So that a corollary of that statement is that between CSV and fixed byte, CSV is much better to use. So, for example, if you are creating a result IFD where you are going to just end up creating an algorithm to send data to DCS, for example, or your real intention is to create XML, then at this level, use CSV, don't use fixed byte, because CSVs are more flexible in case of length changes and stuff like that. So always use CSV if your fixed byte is not an actual requirement. So now we would go a little bit into performance tuning. First and foremost is that all of the integrator's metadata is cached. And expectation of integrator is that once it is running, its own metadata should never be read twice. So there is a table for it, but again, we have to understand that what is the bias of integrator is that it should all be cached. So if you, these numbers are high enough, but if you have to increase them, that's fine. You can increase them to 1000 if you want. But again, very important consideration is that integrator expects that its metadata will not be read twice. So never try to reduce these numbers. The standard values should be enough, but if you have to increase them if there are a lot of customization, that is also completely fair. Basically, cache size is the setting that I'm talking about. Another very important consideration for performance, as I indicated earlier, was synchronous or asynchronous. So first of all, synchronous delivery should be reserved for only exceptional cases. So by default, we never want two systems to be tightly coupled as a default. Of course, we use synchronous typically in case of, for example, we are talking to an automation system, we would go to synchronous communication, but as a default, we don't want to go there. And asynchronous is good, except for asynchronous creates a bottleneck that events go to EC and then we have to create processes to move from EC to IC. So that is where synchronous accept send comes in. That is oftentimes a saving grace by just making your asynchronous to synchronous accept send. Now your events would not stay in EC for long. If you ever seen that issue, that can be solved simply by doing that. What it's really doing is creating a extreme multi-threading, that every process that took to EC also then takes to IC. So that might spend a few milliseconds more, which is not going to be noticeable by the user, but that as opposed to if you had a single process taking care of 10,000 events every few minutes, then that small overhead does add up. So that is why we always prefer to say synchronous accept send instead of asynchronous. And then if you ever have seen the result IFD screen or event maintenance, you see these check boxes there, always persist and persist event data. Those are really talking about the same concept as well. So just imagine if you're doing something synchronously, you don't have to store the intermediate data, right? If you, for example, logged a shipment dispatch, internally integrator figured out what inventory was on it, and then it is going to be sent to another system, for example, in form of a file. Integrator does not have to store the intermediate data, right? That's why these checkboxes come in. So these apply only for synchronous. Because if they're unchecked, then integrator decides. And what would integrator decide? That if it's an asynchronous or synchronous exception, it does need it. So it would always log them regardless. But if they're unchecked and it is a synchronous, then it would not log that intermediate data. That is on the result IFD and event output level, versus on the right side, what you see on event maintenance is at the event level, like event arguments. Again, my default answer there is always that we check all of them. So even in case of synchronous, I want to see this data until we get to a very acute problem where we want to get that last bit of performance out of it. So again, the default answer is that I always check. Even if you have to uncheck it, leave the right side checked, because this is what tells you that this ship load happened for this trailer. And that is very important to easily find transactions later on. So even if you have to uncheck it in certain cases, always leave this side checked. But again, these are only there for synchronous. Then another thing what we can use for performance is first of all use synchronous accept send. Then if you install integrator by standard, you would see an SLIB sender one task, basically, which is responsible to send to all systems like host, SAP, all of those. So disable that and create a task for each system. So you want to make sure that if you have 10 systems that you're sending data, you have a sender task for each of them individually. Then there is a nice switch available at the system communication level for inbound, where you have a run tran flag. If you set it to true, it means that the adapter, which is responsible for getting data, for example, reading a file, reading from a queue, all those, that is also responsible for logging the event, that is creating the part, creating the order. So that means that that is doing a little bit more task. If you set it to false, that means that the adapter is only responsible for creating the download, and you would have a different process processing the download, which is going to be download runner. So that also creates a possibility that you, by decoupling them, you can improve the performance a little bit. And since I think 2012 version, this download runner task has an interesting parameter -e. Just by giving that minus capital E, what it tells is that it is going to use asynchronous runner to even further open up the bottleneck, and multiple asynchronous tasks would be processing those events. So that makes the inbound process very easy to handle. Then there's a specific query which always shows up on Oracle. So the query is well structured. There is nothing wrong in the query, but it basically, because your event statuses are such that there are a lot of events in IC status at a given point, sometimes integrator is not using the proper indexes. So if you just create histograms on Oracle, then this query no longer shows up as a bad query. So that's just a small tip. You just simply create a histogram as described here, and then this query would no longer. Otherwise, this query often shows up as a bad query when analyzing performance on Oracle. So these are some of the tips that always rely on caching. The relying on caching is very important, because sometimes the discussion goes as a, hey, this is slow in integrator. So integrator is never going to be your bottleneck as a general rule. But then when we do a trace shows a lot of noise, which is integrator's own metadata being read. And then oftentimes we get sidetracked and we are looking at those equals. So don't even worry about that, because integrator's own metadata is going to be read only once. So again, rely on caching. And then the performance issues are typically on the communication level or processing algorithms level. Utilize the synchronous accept send, and unchecking the boxes, as I described earlier on the result IFT, can give a little bit of more performance on synchronous. Tune the tasks, and always focus on the processing algorithm and communication layers. Now I would go a little bit into some troubleshooting techniques. One of the things that is very important is finding that transaction. That, what is that item that came for this specific item? What is the transaction for this item? What was the shipment that got dispatched? As I would be going into the data dictionary a little bit later on, but do understand that when we have these checkboxes checked, that's why I always keep them checked, is that your data is in tables SLIB data detail and SLIO data detail packed. I would describe later what packed means, but all of the data is in a table, right? Which basically means that if you have to find data, you can always, SQL is always possible to do in order to find that transaction. And that is something, a very important insight, that finding data is never difficult. Of course, there is a event query screen, those screens are available as well, but they would not allow you to search at the detail level, like which files had this data in them. So in those cases, you can always go to the tables themselves. So this is what I mean by packed. Like when an item transaction came in, there is an actual row in SLIB data detail table, IBSEC data, where you would see a record like this. All of the data is packed together, all the columns, right? So this was defined as a CSV. So all the data is packed together. So you can, of course, just simply do a query on this table where you can say IBSEC data like a certain value, and you would find this transaction number, and then you can figure everything out from there, right? So that is a very simple, easy way to find the transaction. But then I have come across the situation where just a like operation is not good enough. We want to parse out the fields. Like as you can see here, they are packed together, and I want to see it like this. Again, very easy standard command, SL list IFD data field that's available standard, and you would have all of this presentation available as well, so you can refer to it later. So you can call this command for a specific IFD data sequence, a specific detail sequence, and you would see output like this. So in several times I've used this where the specific troubleshooting scenario demanded that I had to look at data like this, maybe then filter for a specific type of palette length or whatnot, and we can do all that via this command. So nothing that should be too intimidating. Then there are sometimes very difficult reprocessing scenarios that something was down for 2 hours, and I want to take this type of transaction for this order and then reprocess those. So again, none of them should be intimidating. Understand that Mocha Integrator is built on top of Mocha, so which means all those things about pipes and selects and everything like that is there natively. So if you don't know about how to do certain reprocessing, very easy technique would be that you go to the standard screen, which is like event query screen, has a resend button, download has a download with trace button. All of those buttons are available. You trace them, and that is always something you would that would expose what Mocha command Integrator itself was using. So when Integrator is sending data to other system, there's a single Mocha command it calls. When it is processing a download, there's a single Mocha command it calls. So which means that if you ever have to do a very difficult reprocessing scenario, you can just simply write a select statement and then pipe it into the appropriate command that Integrator would call. So there's nothing native in Mocha about Integrator, or nothing in Integrator which is native about SAP. All of these are built using Mocha commands. So there are some typical issues that we have seen, and of course there would be more issues as well, but these are some of the typical ones that we often hear, that download is stuck in eProc, right? They're very common. That the most likely issue is that the processing algorithm crashed. So some of the processing algorithms used to be written in C, and there was a memory issue or something like that. Either it's a custom or standard, and that crashed. That would create this scenario where download would be in eProc. Otherwise, eProc is something which is transient. Or there is another one that my event is stuck in IC and it is not moving to SC, but if I click on it and say send, it goes to SC. It's a very typical pain. There, the idea is that Integrator wants to send data to the other systems in order it was sent to it, right? So if this is happening with you, what you should do is find the oldest event in IC, and then you would most likely see what I described in the row above, that event, for some reason, maybe it's a processing algorithm crashing or whatever, is not moving to SC, and that is why your next events are not going to SC either. An Integrator bias is that it wants to send data to the system in order it got in. If it is a situation where you want to just put it aside, you can of course change that event status from IC to XX or something like that. I would have the data dictionary available for you. So that is how you can get through that scenario. Or sometimes it is that it is taking too long to move from IC to SC. So there you might have to multi-thread the sender process, or there could be algorithms that are causing issues. Otherwise, IC in Integrator itself has very little overhead, as it is described, that using caching and whatnot, Integrator itself is not reading its own metadata while doing these things. And then event stays in EC for too long. In that case, you should simply go to synchronous except send. So all the data dictionary itself is what I would go over. Again, this would be a lot of stuff, but don't worry too much about it. The basic message I want to make sure everybody gets is that Integrator's own metadata is in a highly normalized database, which is co-located with WMS's own database. So you can do selects against these tables as you see fit, right? So that implies that you can look up the data, whatever is in the screen in these tables, and none of these things should be too intimidated. It's a highly normalized structure, easy to query. So that is why I'm just describing them here. so that we know what those is. SLSysDef, when I describe about the systems, all systems are described here. Algorithm has all the algorithms. Retrieve method and implementation is where we define how the data is fetched to create the event outputs. Those are all put in here. Like, as you can see, that algorithm ID, what event arguments are there for an event, those are there here as well, like SLEVT-def, EVT-argdef, those are all rows and tables. Event output is defined there as well, IFT-def. So all of that is a highly normalized database, very easy to query, relates very well to what we have on the screens as well. So you can look at a specific event output. If you want to see data behind it, you can go to one of these tables and see all of the data that the screen is showing. And then behind them are Mocha commands as well. So that is what a little bit of a trivia that SL is going to be the prefix for all integrated tables. So SL stands for seamless. That was the first name of integrator, and seamless stood for shared event application management for logistics execution system. So that's why you see SL as a prefix on all of these things. Now, these tables, event execution data, are something which are very important when we are talking about troubleshooting. So very important insight that you can, as you can see, that when an event occurs, you have data for that in SLEVT data. Every argument, like what shipment ID was it, what trailer was it, the scalar input is described there as well. What systems was this event mapped to is in SLIVD sysmap data. So everything is there, which you can easily query. SLEO data header and NEO data detail is the intermediate data for event output, and IFT data and detail are where you can easily go to see what data was sent to the other systems. So that is basically what I was going to cover. One of the questions that I had gotten earlier was around tracing. So tracing itself is a very large question, and we would have probably a separate webinar on just tracing. But tracing in context of integrator would mean that first of all, there's a screens like download, process inbound IFD, and download with trace. If you go to a download viewer screen, you would see a button there to process with trace. So those are some things which are very easy to trace a specific download to get that trace, right? And then if you went to event query, same thing. Or you can at any time within your client, DLX client, you can turn on tracing. And so getting the integrated trace is not that difficult. There are several places available to get it. Now, once you get that trace, integrated traces can be intimidating, because many times when you're tracing it, based on how the tracing works, it would read all of the metadata again, and that creates a lot of noise. So that is where I would typically know that I should bypass all the noise and directly go to the either the SQLs which were used to retrieve data, or the algorithm that were called during it. That's most likely where the performance issues are going to be. So that's basically generative, but the trace itself could be quite large. If you use our Mocha client, parsing a trace which is even a few gigs is not a problem. So that is another thing you can rely. Sometimes I even go down to the file system level to see, use some grep and those techniques. But those are basically in context of integrator. There's a question that popped up that would clear Mocha cache, clear integrator cache also. So no, it will not. Integrator cache can be cleared only by either bouncing the tasks or so when you're some of the processing screens have a reset button there as well. And the slides will be uploaded, yes. All of this would be available along with the video on our website. Can you give me the main web address for following up? Make sure that, Andy, that we send a follow-up email where we send how they can follow up, like
Yep.
SmartEye's website, email address, and whatnot.
Yeah, that sounds good. So I think in our last slide, oh, sorry, I didn't mean to interrupt you.
No, that's all I see so far.
Okay, yeah, so on our last slide, in about 1 or 2 slides, that web address will be on there for you. And then we'll also put it in follow-up communication as well, like Saad said. Todd, you did a fantastic job. If anybody does think of anything that they do want to share with us, they think of it later, they want to submit questions about any future episodes, feel free to do that, like I said, on the website. You can also, we want to make this series as relevant and helpful as possible for you. So if you want to submit any topic ideas or want to talk about anything that we're covering in more detail, you can also, like I said, go to the website and feel free and submit those things to us there. But I think that's it. If we don't have any other questions, Veronica, was there anything else?
Nope.
I think we've covered everything.
No other questions.
All right, well, then the only thing left to do is play trivia. All right, so like I said, we're just gonna have one question, and how it's gonna work is the very first person that answers it via chat, they win the $50 gift card to Amazon. So, all right, here we go. So like I said, just one question, one gift card. We'll send it out to whoever answers via chat first. Question is, what does MoCA stand for? All right, who do we have? Who do we have?
Who is it?
I don't see any answers yet.
Well, there are answers coming on questions. Oh, so
I think, yeah.
so Jawad Khan. So Jawad, I'm not going to give it to you because you already knew it. So sorry. So Aditya Tiwari is who we would give it to. So it's on the question. It's correct. The answer is correct. By thank you, Aditya Tiwari. So that is on the questions, and you should see that there, that they answered it correctly. McHugh Open Component Architecture. Yeah, that is the correct answer. McHugh used to be the old name for Blue Yonder. Before that was Red Prairie. Before that was McHugh Freeman, and that was the McHugh Open Component Architecture. So thank you, Aditya.
Perfect. Thank you so much. All right. I think, hang on 1 second. That is the end of our webinar today. Thank you so much for joining us for this first episode. We hope you'll join us for future episodes. Like I said, we would love to hear from you and get your feedback. We want to be as interactive about this as possible. So do please share your ideas and requests with us along the way. We hope to see you on the next event.
All right.
Thank you.
Thank you. Bye.
Thanks, guys.